Hello, I'm the magnetised Mr. Daycock, and today I'm going to be teaching you how to solve second order differential equations where the auxiliary equation has equal roots. Now make sure you've watched the previous video to ensure you know how to solve second order differential equations with the standard auxiliary equation. Let's have a look at this example. So, exactly as before, we can just write down the auxiliary equation from the coefficients. We've got it in the correct form, it equals 0. Everything's good, so our auxiliary equation is going to be alpha squared plus 6 alpha plus 9 equals 0. And now, unsurprisingly, given the title of the video, this is going to factorise to x plus 3, or x plus 3 squared. And so we have two roots, but those roots are equal, not x alpha. Two roots, but they are equal. And now at this point we should be able to just write down our answer, our general solution. So our general solution should be y equals a e to the minus 3x plus b e to the minus 3x. Seems reasonable? Seems like it makes sense. Unfortunately, it doesn't quite work. And the reason it doesn't quite work is because this is a constant and this is a constant. So in fact we can just factor out that e to the minus 3x and we get a plus b e to the minus 3x. And now a plus b, well, if a is constant and b is a constant, a plus b is just a constant. So I'll say a plus b equals c. And now I've got this is equal to c e to the minus 3x. And this is just now has a single part. It has a single unknown, a single variable in our general solution to give us all our possible different ones. But we know that from it being a second order differential equation, that it should have two arbitrary constants, two unknown constants that we can find out potentially with initial conditions or given information. So something has gone wrong because it's only got one arbitrary constant. Yeah, it comes from this a and b, but ultimately that doesn't give us any extra information. The fact that it's two constants added together, there's still no way of getting two bits of information, and that is vitally important. So we need to come up with a solution for that. Now I will have a separate video on this, but the solution is actually pretty simple. We know we want something in the form of a e to the minus 3x. Ooh, too many e's there. Minus 3x. Now for the second term, we still want e to the minus 3x because we still have that repeated root. We need to differentiate it somehow. And the way that's done is we just plug in an extra value of x in front. Again, this does seem kind of arbitrary, y and x. It turns out that's the thing that works, and I will have another video explaining why. But this here is our general solution. If you have equal roots of the auxiliary equation, you just need to have that extra x on the other term, and sometimes it's written as y equals a plus bx e to the minus 3x. Sometimes it's written like that. But the key thing is that now these don't just add together into a single constant because this b is being affected by the x. Again, another video on why that will be true in a moment or in the next video. But for now, let's just use that information. So as always, auxiliary equation, we get 1 alpha squared minus 4 alpha plus 4 equals 0. This factorizes to alpha minus 2 squared equals 0, and so we get alpha equals 2. And therefore our general solution is y equals a e to the 2x plus b e to the 2x, except we need to make sure the second one is different with this x in here. And there we go. That's all there is to it. Nice and simple. just make sure that you need to add that extra x to make sure you get those two distinct parts to the general solution. So we have two arbitrary constants. Okay, thank you very much for watching, and I'll see you in the next video.